In this session, let's look at some mathematical functions. So let's say a equal to 5 log to the base 10 of a. So for that the function is log 10 of a. Now log 10 is not defined. Why? Remember, some of the functions are directly available, and for some of them you have to import math. So import math, and because I don't want to use math dot every time, I can say from math import everything, that is star. Now let me give the exact same log 10 of a. Yes, okay, log to the base e, that is a natural log. So for that, just a log of a. Now e to the power of a. Now e to the power of a. Okay. Now e, from where is it coming? Right. E is coming from math. In math, there are certain constants which are already defined. E to the power of a to the power of 2. E to the power of e to the power of a. Let's look at some trigonometric functions. So let's say theta is equal to pi by 3. A is equal to 0.5. Sine of a. Sine inverse. Now how do I show sine inverse? For that, a sine. A sine is arc sine, which is nothing but inverse of sine. So a sine of pi by 3. That is, we have defined it in theta. So theta. Math domain error. What does this mean? It means that the function only accepts an argument within a particular range of values, which in maths we say domain. So instead of saying theta, let's say a sine of a. The domain of arc sine is from -1 to 1. Shall we see whether that's true or not? Let's say a sine 1 is 1.57. A sine of 1.00001. Let's look at it from the other side, -1. A sine of -1. A sine -1 is, it is giving. But what if I say a sine minus 1.000? It's a very small distance from -1 to this number. Again, domain error. Okay, so whenever you get a domain error, math domain error, just remember that the value that you are providing to the function is something which is beyond its domain. Sine inverse of a square. So star 2. Now sine square theta plus cos square theta. Sine theta square plus cos theta square should give you 1. Cosec square theta plus sine square 1 by theta. So cosec square theta, that function is not available. We have to actually take it as 1 by sine theta square plus sine 1 by theta square. Now let's say we are given x equal to 60 and y is equal to 30, and we are asked to find sine of x plus y. So sine of x plus y. Sine of x plus y actually comes to sine of 90, and sine of 90 is supposed to be 1. It is giving us a very different value. That is because we are providing it in degrees. We have to provide it in radians. So basically the way to look at it is treating 60 as if it is in radians. Okay, so let's convert it into radians. Let's say A is equal to radians of x, B is equal to radians of y, radians. Okay, so if I say A, B, these are the radian equivalent of 60 and 30. Okay, so A and B are in radians now. So sine x plus y. No, now we should not use x plus y. We should use A plus B. And this it should give us as 1. Okay, sine x cos y. Sine x, we have to specifically say multiplied by cos y plus cos x times sine y. Again I made the mistake. Instead of giving x and y, I should have given a and b. A, B. Yes. Okay, sine x, no, a minus b is 0.499. Sine a times cos b minus cos a times sine b, 0.5. Now they should actually come exactly equal to, but some level of approximation has taken place here. So for 0.49999 is equal to 0.5 for all practical purposes. Okay, tan A plus B. Now tan 90 is supposed to be undefined. Yes, but here it is giving us a value. So remember in Python it will give you a very large number which we can treat it as infinity. Okay, because when you take the limit it approaches infinity. Okay, what about tan inverse? Again a tan A times B, sine 2x, let's not say 2x, let's say 2 times A, we have to say in radians, so A. Now we know what is the formula for sine 2A. 2 times sine A times cos A. Exactly the same values except the last digit. Okay, cos 3x, 3 times A, not x, 3A plus sine 2 times A, cos 5 times A plus sine 2 times y minus cosec. We don't have a cosec function, so within brackets 1 by sine of 5 times x plus 2 times y and square, so square and enter. Cosec square x square, so again 1 by sine of x square, so x square within bracket and then a square outside. Okay, some more functions. Sine of pi by 2. Now pi is defined in math. Sine of 3 pi by 2. So within brackets 3 times pi by 2. Cosec, again remember no cosec, so we have to say 1 by sine of 2 by pi. Cot, again cot is not defined, so we have to say, take it as 1 by tan of 55 by 66 times pi square, 1 bracket less, so now okay, 64 tan square 3 pi square by 5. Okay, now this we need to be a little bit more careful. So 64 times tan square, so tan, let's take care of the brackets later, so tan of 3 times pi square by 5 plus 38 times cosec square. So that is 1 by sine 3 times pi square by 5 and the square of this cosec, and the tan also should be square. So square, and press enter. Okay, closing bracket. Now what we can do is, just to make sure that it is coming properly, we can take it step by step. So we can say 3 by 5 is 0.6 pi square, right? What we'll do is, let's store it in q. So q is equal to pi square. So now what we'll do, we'll say 0.6 times q, so 5.92. Now we have to take the tan of this. So let's again store it in a variable. So T1 is equal to 0.6 times Q. Now we have to take the tan of T1 square. Now this we have to multiply it with 64. So this 64 times this. So we get this. So similarly we do for 38 cosec square 3 pi square by 5, and then add those two results. Okay, just try it out. Now similarly cosec square, again cosec is not defined, so 1 by sine of 437 times pi cube. Now we have to use the power function. So power of pi comma 3 pi cube divided by 537, closing bracket. Now sec, again we don't have sec function, we have to use 1 by cos. 1 by cos of pi square by 2, cos of pi square by 2 plus, and we should be careful. So let's pi square by 2, let's put it in brackets, and then within brackets again another brackets, let's take 34 pi to the power of 5 by 7. So 34 times power of 5 comma 5 by 7. Again we can use brackets to group them, and divided by 7. Yes, I have done that. Closing bracket. Again one more closing. Okay, I think you got the idea. Remaining I leave it up to you, but please do try and practice a lot. Bye for now.